Can you see the group of stars in the sky? That's our Milky Way galaxy. One of the biggest challenges faced by astronomers today is understanding how the galaxies are formed. First, you have to know what galaxies are. Galaxies are collections of stars, gas, dust and dark matter, held together by gravity. Their appearance and composition are shaped over billions of years by interactions with groups of stars and other galaxies. Using supercomputers, scientists can look back in time and simulate how a galaxy may have formed in the early universe and grown into what we see today. Galaxies are thought to begin as small clouds of stars and dust, swirling through space. As other clouds get close, gravity sends these objects rush into one another and unites them into larger spinning packs. Subsequent collisions can swing material toward the galaxy's boundary, creating extensive spiral arms filled with colonies of stars. Observations by Hubble Space Telescope and ground-based instruments show that the first galaxies took shape as little as 1 billion years after the Big Bang, which probably took place about 13 billion to 14 billion years ago. There are two leading theories to explain how the first galaxies formed. The truth may involve a bit of both ideas. One says that galaxies were born when vast clouds of gas and dust collapsed under their own gravitational pull, allowing stars to form. The other, which has gained strength in recent years, says the young universe contained many small groups of matter, which groups together to form galaxies. Hubble Space Telescope has photographed many such groups, which may be the precursors to modern galaxies. According to this theory, most of the early large galaxies were spirals. But over time, many spirals merged to form ellipticals. The galaxy formation process has not stopped. Galaxy mergers can occur when two or more galaxies collide. They are the most violent type of galaxy interaction. The gravitational interactions between galaxies and the friction between the gas and dust have major effects on the galaxies involved. Our universe continues to evolve. Small galaxies are frequently eaten up by larger ones. The Milky Way may contain the remains of several smaller galaxies that it has swallowed during its long lifetime. The Milky Way is digesting at least 2 small galaxies even now and may pull in others over the next few billion years. Galaxy mergers happen fairly often. A large portion of the bright galaxies that we see today may have formed from the mergers of 2 or smaller galaxies. Mergers are common because the universe is crowded on the galactic distance scale. The disk of the Milky Way, for example, spans about 100,000 light-years. The nearest major galaxy, the Great Spiral in Andromeda, which is a little bigger than the Milky Way, is about 2.5 million light-years away. That means the distance between these two galaxies is only about 25 times greater than the sizes of the galaxies themselves. That doesn't leave a lot of elbow room for galaxies. Galaxies are very massive too, so their gravity is strong. When you crowd them together, the attraction can be so strong that two galaxies hook onto each other and don't let go. Eventually they merge, forming a single giant city of stars. The largest galaxies are giant ellipticals. They look like eggs or football. They can be 10 times the Milky Way's size and contain more than 1 trillion stars. Such galaxies probably form on 2 or more spirals, like the Milky Way, merge to form a single galaxy. One bit of evidence supporting the merger theory is a large number of ellipticals in dense clusters of galaxies, where mergers must be common. Two giant ellipticals dominate the center of the densely packed Coma cluster. For example, and the heart of the Virgo cluster contains three giant ellipticals that each span almost 1 million light-years. Mergers can take anywhere from a few hundred million to a few billion years to complete. They can trigger intense bursts of new star formation, and even create gigantic black holes. Galactic collisions rarely produce head-on wrecks between individual stars. Even when two galaxies ram together, the distance between stars is enormous. Yet stars can suffer ill effects from the collisions. They can be thrown into new orbits, or even thrown clear of their parent galaxies into intergalactic space. While galactic collisions rarely destroy stars, they often create them. As vast clouds of gas and dust in merging galaxies, they can create thousands or even millions of new stars. Most galaxies have black holes at their centers that can produce a tremendous amount of energy, which astronomers can see over great distances. In some cases, a galaxy's central black hole is extremely large or active. Even in relatively small galaxies, material circling the black hole may be accelerated outward by its jets. Other galaxies may contain quasars, the most energetic bodies in the universe. At their core, galaxies are classified by their shapes. Each type has different characteristics and a different history of evolution. Some, like the Milky Way, have arms spiraling outward around their center, known as spiral galaxies. These groups make up most of the galaxies that astronomers can see. The gas and dust in a spiral galaxy circles the center at speeds of hundreds of miles per second, creating their pinwheel shape. Some, known as barred spirals, have a bar structure in their center, formed by dust and gas funneled into the center. The dust and gas in spiral galaxies are consistently fueling the formation of new stars. Elliptical galaxies lack the spiral arms of their more energetic cousins. Their appearance ranges from circular to very stretched out. Elliptical galaxies have less dust than their spiral counterparts, and so the star-making process has all but ended. Most of their stars are older, although they make up a smaller portion of the visible galaxies. Astronomers think that over half the galaxies in the universe are elliptical. The remaining 3% of the galaxies in the universe are known as uneven galaxies. They are neither round nor spiral arms, and their shapes lack specific definition. The gravity of other galaxies has often affected them, stretching them out or warping them. Collisions or close calls with other galaxies can also deform their shapes. Galaxies don't sail through space in isolation, but are bunched together in groups, known as clusters. Some clusters are large, containing over 1,000 galaxies, while others are much smaller. The Milky Way lies within the cluster known as the local group, which only contains 50 galaxies. Occasionally, galaxies bang into one another, merging their stars and dust together. This is an important step in the evolution and growth of many galaxies. In late 2018, astronomers released a study showing two supermassive black holes crashing into one another in the final stages of a galactic smash-up, representing the first time such a late stage of galaxy collision was seen in action. Individual stars generally don't collide in a galactic collision, but the flood of dust and gas bangs up the rate of star formation. The Milky Way is set to collide with the Andromeda Galaxy in about 5 billion years. And collisions have occurred in its earliest past as well, not to be surpassed. The Andromeda Galaxy probably ate up one of the Milky Way's early siblings too. If you enjoyed this video, then give a thumbs up, and let us know which of these are your favorite in the comments. And if you like the video, then make sure to subscribe and turn on notifications, so you will be the first to know when the video arrives. Thanks for watching.